Let us discuss about error of closure. Now, there's no such thing as a mathematically perfect survey. Small errors in both distances and angles will always be present, even in close traverses observed using instruments and methods of high precision. So, in all probability, surveyed close traverse would not satisfy the geometric condition. That is, the sum of the departures and the sum of the latitudes must equal to 0. So that is the geometric condition. In all likelihood, it will not be satisfied. So until adjustments are made to these observed quantities, it will always be expected that the traverse will not mathematically close. So if we are going to make a sketch of the traverse based on the observed values, now say these are the station points A, B, C, and D. Now, it is supposed to close at A, but because of some observational errors, it will end up at a point we can denote it as A prime. Now, this is actually, this line connecting A prime A is what we term as the linear error of closure. The linear error of closure. Okay? So what we are going to do is we are going to get the magnitude, no, of the linear error of closure as well as its direction. Now, the linear error of closure is simply the square root of CL squared plus CD squared. Now, what does CL stand for? CL is the misclosure in latitude. No? Misclosure in latitude. And CD is the misclosure in the departure. So if both CL and CD are equal to 0, no adjustment is necessary. Now you can think also of CL as the summation of all the latitudes and C sub T as the summation of all the departures. Now how do we determine the direction? The direction is simply arctangent of the negative of CD over the negative of CL. Okay, so in this illustration, our CL and our CD are both negative. No? The misclosure in latitude is negative. There are more negative latitudes than there are positive latitudes. That is why it is located down below A, the station, down below station A. And for departure, it is negative because it is located left of A. So the linear error closure here will be in the northeast direction. No? Net negative for latitude, so it should be south. Net negative for the departure, it should be west. Taking the opposite direction of southwest, that will be northeast. So the linear error closure for this particular example runs in a northeast direction. All right? So CL is the misclosure in latitude and CD is the misclosure in the departure. So if any one of them or both of them are not equal to 0, then we have the linear error of closure. We are simply applying here Pythagorean theorem. So that is our CD and our CL. The correction, the misclosure and departure, and the misclosure in latitude. Okay? Let us now work on the following problem. Given in the accompanying tabulation are the observed data for a closed traverse. we determine the following: the misclosure in the departure and the latitude, meaning the summation of the departures and the latitudes. Then, based on this, we'll be able to calculate for the linear error of closure, and finally, the bearing of the side of the error, or simply the direction of the linear error of closure. So we have the following lines: A, B, B, C, C, D, D, E, E, F, and F, A, with the corresponding lengths and azimuths. So first thing first, we have to calculate for the latitudes and the departures. No? So we have to write down the latitudes and the departures of the traverse lines. For the latitude, what is our formula in finding the latitude? That is equal to the distance multiplied by the cosine of the azimuth or the bearing. And for the departure, it will be the distance or the length of the course or the line times sine of the angle or the bearing. Since the direction is given in terms of the azimuth, we will have no problem as regards the directions or the signs rather of the latitudes and the departures. So beginning with line AB, so latitude of line AB will simply be equal to the length or the distance of AB times cosine of the azimuth 122.30. So let us write the value. The length is 233.10 times cosine of 122 degrees and 30 minutes. And that should give us negative 125.24. Negative 125.24. For the departure of line AB, we'll just use the sine function, no? Sine of 122.30, and that should give us 196.59 positive, no? 196.59. And we will do that for all the remaining traverse lines. For line BC, the length is 242.05 times cosine of 85.15, which is 20.04. As for the departure, it will be 241.22. Both positive. No? Azimuth of 85 is in the northeasterly quadrant. So both latitudes and departures are positive. For CD, the latitude is 191.50 times cosine of 20, which should give us 179.95. 179.95. And then, as for the departure, 191.50 times sine of 20, that is 65.50. Again, both positive. Then for DE, that will be DE. That will be 209.98. 234.46 times cosine of 333 degrees 35 minutes, and 234.46 times sine of 333 degrees and 35 minutes will give me negative 104.34. Wait, for the 104.31. 104.31. Yes. And then EF 270.65 times cosine 254 degrees and 8 minutes. That should be negative 74.00. 270.65 times sine of 254 degrees 8 minutes will give us negative 260.34. Then FA, latitude 252.38 times cosine of 213, that is negative 211.66. The departure 252.38 times sine of 213 should give us negative 137.46. Okay? So what we do next is we simply sum up all the latitudes, which gives us CL. So we have to add negative 125.24 plus 20.04 plus that until negative 211.66, and CL must equal negative 0.93. So it is net negative. No, it's net negative. So we will find our terminal point down below point A. No? If this is our initial station A, it ends at a point lower than A. So somewhere here because it is net negative for the latitude. How about for the summation of the departures? The summation of the departures is CD, that is 196.59 plus 241.22 plus and so on and so forth up to negative 137.46, and CD must equal positive 1.20. So meaning to say, there are more east departure than there are west departure. So the initial point is at A, and the traverse ended up at a point lower than A and to the right of A. So somewhere here, it ended up at A prime. So here is our linear error of closure. Okay? So that is our linear error of closure. Okay. So let us calculate for the linear error of closure. The linear error of closure is equal to the square root of CL squared plus CD squared. So that is the square root of negative 0.93 squared plus 1.20 squared, and that is equal to 1.52. We also refer to this as the misclosure. So we ended up at a point A prime, 1.52 meters, where we are supposed to end. No? The initial point is A. We are supposed to end at A, but we ended up at a point A prime, 1.52 meters away. How about the direction? The direction is arctangent of the negative of CD over the negative of CL. So that should give us, actually we can just get the absolute value. So arctangent of, but anyway, let us apply the formula. Negative of positive is negative 1.20 over negative of negative positive 0.93. So we will end up here with a negative value, so arctangent of that is negative 52 degrees and 13 minutes. And what will be the direction? What is the direction of the linear error of closure? Net negative for the latitude, so opposite to that it will be north. Net positive for the departure, so opposite to that is west. So that is 52 degrees and 13 minutes, no? From A prime to A in a northwesterly direction. Okay? So more or less, what is the sketch of the traverse? What is the sketch of the traverse? So 122, it's somewhere here, and then 85 going there, then positive 20 over there, 330 will be, okay, make it shorter. 333, so it should be somewhere there. Then 254, and then 250. Okay, so and then 230. Okay, so that is supposed to be the sketch of our traverse. If you want a better illustration for the traverse, then you use a scale. Alright, so that's it. The linear error closure is 1.52 meters and it runs north 52 degrees 13 minutes west.